My name is Akshay Kumar. Today we are going to discuss coordinate geometry. See, this coordinate geometry is very important for the exam point of view, and not only for exam point of view, this is also important in the engineering department and for the scientists also. Now the question arises, what is the need to set this coordinate? Suppose we have to locate that your school is at some distance from your house. Now the question arises, suppose it is 5 km. The question is, how can you say it is 5 km? See, whenever we denote a distance of any two objects, it is with respect to something. You cannot arbitrarily just denote any distance. It is with respect to some. Now see, what are those with respect to? We will study all these in detail, don't get worried. See, coordinate geometry is divided into two parts. The first is the 2D coordinate geometry and the second one is 3D coordinate geometry. But in your syllabus only 2D coordinate geometry is, so our whole emphasis will be only on 2D, not in the 3D. See what happens. The first thing is, I think the meaning of the importance of coordinate geometry is understood by everyone. Now starting from the fundamental, this is in the previous class. See, we are 2D means xy plane. Horizontal axis is the x dash, that is the horizontal axis, and vertical axis is the y dash. So what will happen? See, it is known as Cartesian plane. The x dash is the horizontal axis, y dash is the vertical axis. So they intersect each other at 90 degrees, and the point at which they intersect is termed as origin, denoted by O. With all these distances are taken with respect to this origin. So what will happen? This whole figure has been divided into 4 equal parts. These 4 parts are known as quadrants. First quadrant, second quadrant, third quadrant, fourth quadrant. See, when we go on the right of this origin, the x-axis is positive. On the left of this origin, the y-axis is negative. When we go vertically of the origin, the y-axis is positive, and below the O, the y-axis is negative. So in the first quadrant, both the x and y coordinates are positive. In the second quadrant, the x axis is negative, it is negative positive, x is negative, y is positive. In the third quadrant, both x and y axis or coordinates are negative, and in the fourth, now the x axis is positive, whereas the y axis is negative. Clear? Now see, this is the first fundamental concept. Now some formulas we have to discuss. The first formula is the distance formula. See, suppose there are 2 points such as Delhi and Bombay. Suppose P is denoting Delhi and Q is denoting Bombay. We have to find the distance between Delhi and Bombay, or any 2 cities, or Delhi, Kolkata, or any 2 cities you take. Now how the distance found? Using this coordinates. See, the x coordinate we are discussing only the xy plane, so we will not discuss z coordinate or the z plane. So P is x1 y1, Q is x2 y2. What will happen? We have to find the value of PQ. You will use the Pythagoras theorem. So you have read the Pythagoras theorem in the previous class. For a right angle triangle, the length of a square of hypotenuse is equal to the length of the square of the sum of altitude and the base. See, this is the right angle triangle. PQ is right angle triangle. How it is like that we will discuss. See, P and Q are 2 points. We will draw perpendicular from Q to R and Q to S, and we will draw PT parallel to this x-axis. So PQT becomes a right angle triangle, which is right angle at T. Now what will happen? See, PQ you have to find out. From the right angle, from the Pythagoras theorem, this PQ square equals to summation of PT square plus QT square. PT is C. PT is what? X coordinate of this T is x2 and x coordinate of this P is x1. x2 minus x1. QT is y coordinate of this Q is y2, and y coordinate of this T is y1. Clear this point? So y2 minus y1. Okay, so PQ equals to under root x2 minus x1 the whole square plus y2 minus y1 the whole square. This PT is OP minus OP. Okay, this minus this, that is the thing. This proof they can ask to learn this formula. And see, this distance formula is utilized. All the distance are being found using this distance formula. Now second thing which you have to read is the section formula. See, suppose there are 2 points forming a line segment. Now what happens? Line segment is a part of a line. Now A and B are 2 points which form a line segment. There is a point P which divides this line segment in the ratio m1 is to m2. So we have to find the coordinates of this point P. Now the question is, this what are the coordinates of this point? See, Let the coordinates of point P be x, y. See, let the coordinates of this point be x, y. So what we will do, the ratio is m1 and m2, and the coordinates of A point is x1, y1, and the coordinate of B point is x2, y2. So what we will do, see, you might have read the similarity. The similarity concept has been discussed in the previous class. This triangle APQ and triangle PBC, these two triangles are, we have to prove them as similar. We have to prove them as similar. Now the question is, how will we prove them similar? See, AR perpendicular to, before that let me explain. AR perpendicular to x-axis, BP perpendicular to x-axis, PS perpendicular to x-axis, okay? 90 degrees. AQ parallel to x-axis, PC parallel to x-axis, okay? So what will happen, this angle PCB and angle AQP, it will be 90 degrees. Obviously this angle and this angle will be 90 degrees. Now this parallel to this angle equals to this angle, okay? Using AA similarity criterion, angle similarity criterion, this triangle PAQ, see, PAQ is similar to BPC. While writing this similarity, you have to be very much sincere. See, PAQ is similar to B. You cannot write it PBC. You have to write in BPC. PC, suppose, see, let me show you. This angle equals this angle. This way the similarity criterion is right. Now, PA upon BP equals to QA upon CP, okay? Equals to PQ upon BC. See, P is here, Q here, so it will be B and C, okay? Written. Now we have to find the value of this QA, CP, PQ, BC, because the ratio of AP upon BP is M1:M2. Clear to everyone? So what we will do, ratio of PA upon BP is M1:M2. Find the value of QA. This is QA. The x coordinate of Q is x and the x coordinate of A is x1. So QA equals to OS minus OR, that is x minus x1. The x coordinate of this CP is this one. Find x coordinate of C, that is x2. X coordinate of P is x. This x2 minus x. Similarly, we have to find the value of PQ. This PQ, y minus y1, y2 minus y2. How to find this QA, CP? This will be used in every. So try to understand this very sincerely. Now put the values here. M1 upon M2 equals to x minus x1 upon x2 minus x1 equals to y minus y1 upon y2 minus y1. Now what you have to do? Forget this part. M1 by M2 equals to x minus x1 upon x2 minus x1. So M1 into cross multiplication, M1 into x2 minus x1 equals to M2 into x minus x1. M1 x2 minus M1 x2 minus M1 x1 equals to M2x minus M2 x1. When we will just rearrange that, because only x is unknown, so put the terms of x on the LHS, left side of this equation. So and that we get x equals to M1 x2 plus M2 x1 upon M1 plus M2. Okay. See, the same concept will be used to find the value of this unknown y in the second equation. M1 by M2 equals to y minus y1 upon y2 minus y1. So M1 into y2 minus y1 equals to M2 into y minus y1. Okay. So y equals to M1 y2 plus M2 y1 M1 plus M2. Simple cross multiplication, nothing more you have to do. Okay. Nothing more. This thing and this thing you have to learn and prove, because they will ask in the board examination. Clear? Now coming on the area of triangle C. There are different formulas to find the area of triangle. The easiest is the area of triangles to half into base area. Okay. Base is the height is this perpendicular distance. Now the main thing which we are considering is this formula, area of triangle when the 3 points along with coordinates are given. See, we have to just find out the formula, how this formula has been taken. See, what will happen? The coordinates of A is x1 y1, B is x2 y2, C is x3 y3. Okay. So what we will do? Draw perpendicular from B to x-axis, A to y x-axis, C to x-axis. DQ perpendicular to x-axis, AP perpendicular to x-axis, and CR perpendicular to x-axis. Okay. So what we will do? Join A with B, B with C, A with C. If we have to find the value of only this part, C. If we find the area of AB, PQ, AP, RC, and BC, RQ. So find the area of AB, QP, AP, RC, and add them and subtract the area of BCRQ from the area of summation of area of this one and this one. Now what this ABPQ is? BQ parallel to AP, only one pair of parallel sides. This AB is not parallel to QP. This is a trapezium, because a trapezium one pair of parallel sides are there. Similarly, APRC is a parallelogram and BCRQ is also a parallelogram. Now see the formula for the area of parallelogram. This we trapezium. This is not a parallelogram. This is a parallelogram. Sorry, not a parallelogram. It's a trapezium. See, ABQP is a trapezium and APRC is a trapezium. By mistake I told it parallelogram. I consider it is a trapezium. Similarly, BCRQ is also trapezium. What happens in the case of trapezium? This formula is, again I am repeating, by mistake I told it parallelogram. It is not parallelogram. It is trapezium. Okay. See, the area of trapezium equals to half into sum of parallel sides into distance between them. This formula you have to directly learn. The area of trapezium equals to half into sum of parallel sides into distance between them. See, area of ABPQ, half into sum of parallel sides BQ, AP into QP. Area of this APRC, half into AP plus CR into PR minus BQ plus CR into PR. Okay. Using this formula, this QSCP, we will just find this. I have already found out this. Or you can learn also. Y2 plus Y1, X1 minus X2. This is the formula. Now the main thing is that from here to here, what you have to, very easy. Open the bracket. Y2 X1 minus Y2 X2. Y1 X1 minus Y1 X2. Okay. Take half as common. Y1 X3 minus Y1 X1. Y3 X1 minus Y3 X3 minus Y1 3 X1. Okay. Then Y2 X3 minus Y2 X2. Y3 X3 minus Y3 X2. Change the sign according to this, and when we will solve it, see, area of triangle ABC is half into X1 into Y2 minus Y3 plus X2 into Y3 minus Y1 plus X3 into Y1 minus Y2. This is a very important formula which you have to learn. Okay. This formula, area of trapezium equals to half into sum of parallel sides into distance between. This we have read in the previous class. Now see, there are some of the questions. Time might not get lost. I have solved this question before, but I will just put my hand here and I will explain this. See, I have solved this before so that the time might not get lost in solving this. See, there are 4 points. Show that the points 1, 7, 4, 2, minus 1, and minus 4, 4 are the vertices of a square. Okay. So what we have to do? Suppose the points are A, B, C, and D. Okay. The coordinates of A are 1, 7, B, 4, 2, C minus 1, and D minus 4, 4. Okay. So what we will do, using the distance formula, see, distance formula equals to under root x2 minus x1 the whole square plus y2 minus y1 the whole square. What happens in the case of A and B, the x1, y1 is 1, 7 and subtracted here, x2, y2 is 4. So AB is x2 minus x1 the whole square plus y2 minus y1 the whole square, 4 minus 1 the whole square plus 2 minus 7 the whole square, 4 minus 1 is 3, 4 minus 1 is 3 and 2 minus 7 is minus 5, but for squaring it has written as plus 5 because minus into minus becomes out to plus. 3 square is 9, 5 square is 25, 25 plus 3 is 34, okay, under root 34. BC is minus 1 minus 4 written minus 1 minus 2, that is minus 5 the whole square plus of minus 3 the whole square, that is 5 square plus 3 square, 25 plus 3 that is 34, okay, 25 plus 9 that is 34. Similarly we will find the CD, minus 4 plus 1 plus of 4 plus 1 that is 5 square plus of minus 3 square that is 25 plus 9 that is 34, okay. Now we will find the 4 that is DA under root 1 plus 4 the whole square plus 7 minus 4 the whole square, 5 square plus 3 square that is 25 plus 9 that is 34. See, the length of 4 sides AB equals to CD equals to AB equals to BC equals to CD equals to DA, that is under root 34. But to have a square the length of diagonals must be equal, that is AC must be equal to BD. Now in this case the x1 y1 will be 1 7 while the x2 y2 will be minus 1 minus 1. So AC equals to minus 1 minus 1 the whole square plus minus 1 minus 7 that is minus 8 the whole square, that is under root 8 square plus 2 square, that is 64 plus 4 that is 68 under root 68. Now we have to find the value of BD, that is the same thing, under root minus 4 the whole square plus 4 minus 2 the whole square, that is 8 square plus 6 2 4 2 square, that is 64 plus 4 68, okay. AC equals to BD, we are forming a square first. Now the next question is, see, So this question I think everybody clear. Find that all the sides are equal in length, diagonals are equal in length. AB equals to BC equals to CD equals to DE and AC equals to BD. Okay, this happens in the case of square. So the diagonals are equal in length and the sides are equal in length. So it forms a square. Next question, find the relation between point X and Y such that point XY is equidistant from the point 7 and 3. A point XY is given. We have to find the relation between X coordinate and the Y coordinate is such a manner that this point is equidistant from a point which is having coordinates 7, 1 and 3, 5. See, what will happen? Suppose this is a point P, X. It is equidistant from this also and this also. I don't understand. So this A, PA equals to PB. So what we will do? PA equals to PB, obviously equidistance. Suppose this is equidistance, is written. Now if we square the both sides of AP and BP, so what will happen? AP square equals to BP square. Why I have done that? The square will be removed. So x minus 7 the whole square plus y minus 1 the whole square equals to x minus 3 the whole square plus y minus 5 the whole square. Clear? Open the brackets. X square minus 14x plus 14 equals to y square minus 2y plus 1 equals to x square minus 6x plus 9 plus y square minus 10y plus 20. Clear everyone? Now we will just eliminate this plus y square because they are on the both sides of this equation. Just if we transpose it, x square will come here, y square will come here, both will get eliminated. I directly eliminate it. Minus 14x plus 49 minus 2y plus 1 equals to minus 6x plus 9 minus 10y plus 25. This step, after that step, what I have done, take this on the LHS. 14 minus 14x plus 49 minus 2y plus 1. We will transpose. Transposition you have might read in the previous classes. Plus 6x minus 9 plus 10y minus 25. Minus 14x plus 6x minus 8x. Because minus 14x sign is bigger, so it will be minus 8x. Minus 2y plus 10y plus 8y. 49 plus 150. Minus 9 minus 25 minus 34. Okay. Minus 8x plus 8y, 50 minus 34 comes out to 16. See. Minus 8x plus 8y plus 16. We will take minus 8 as common. So x minus y minus 2 will be there because obviously sign will get changed. Now my x minus y minus 2. What I have taken the 2 and the RHS, means on the right hand side of this equation. So it will be x minus y equals 2. Okay. Now see next question. Find coordinates of the point that divides the line segment joining points 4 minus 3 and 8 5 in the ratio 3:1 interval. See in this case what happens? 2 points are given and a point P is dividing it in the ratio 3:1 interval. So what do we do? x1 by 1 is 4 minus 3, x2 by 2 is 8 5, m1 is 23:1. Okay. So we have to find the x coordinate. We have read in the section formula m1 x2 plus m2 x1 upon m1 plus m2. Okay. m1 is 3, x2 is 8. I have written this also x1 by 1 x2 by 2. y1 is m2 is 1, x1 is 4. 3 into 8 plus 1 into 4 upon 3 into 3 plus 1, that is 24 plus 4, that is 28 upon 4. 3 plus 1 comes out to be 4. 24 by 4, 24 plus 4 by 4, that is 28 by 4, that is 7. Okay. Now we will go on the y coordinates. m1 by 2 plus m2 by 1 upon m1 plus m2. What we will do? 3 into 5. m1 by 2, 3 into 5 plus 1 into minus 3. Okay. 3 into 5 is 15. 1 into minus 3 is minus 3. Obviously, 15 minus 3 comes out to be 12. Now 3 plus 1 4. We will not change sign in the denominator. Keep this thing in mind. 3 plus 1 4. So it will be 12 by 4. That is 3. So the coordinates of P will be x coordinate is 7, y coordinate is 3. So it will be 7 3. We have to find the coordinates of point P that divides these points in the ratio 3:1 interval. It will be 7:3. Okay. Now find the ratio in which y-axis divides line segment joining the points 5 minus 6 and minus 1 minus 4. Also find the point of intersection. See, the question states that we have to find the ratio in which y-axis is dividing the line segment, that is a 5 minus 6 and minus 1 minus 4. We have to find the ratio in which y-axis divides. So what we will do? See, let the ratio be k:1. Okay. Let the ratio be k is to 1. A is x1 y1, 5 minus 6, B is x2 y2 minus 1 minus 2. So if the ratio is k is to 1, see this is the ratio, try to understand here. M1 x2 plus M2 x1 upon M1 plus M2. Here M1 takes the form of k, M2 takes the form of 1. My k into minus 1 plus 1 into 5 upon k plus 1. K into minus 4 plus 1 into minus 6. That is minus 4k minus 4. Or k plus 1. So this is the x coordinate, this is the y coordinate. K into minus 1, that is minus k plus 5 upon k plus 1. And y coordinate is k into minus 4 plus 1 into minus 6 minus 4k minus 6 upon k plus 1. So what will happen? See, the question is this: y axis divides the line segment. So if the y axis divides the line segment, now so obviously the x coordinate or the equation of y axis is x equals to 0. Means the x coordinate is 0 on the y. So obviously this x coordinate comes out to be 0. Okay. So minus k plus 5 upon k plus 1 equals to 0. This k plus 1 going on the RHS, it will comes out to be 0. Minus k plus 5 equals to 0, so k equals to 5. Okay. Now we have to find the y coordinate. See, we have to find the value of k, that is 5. Find the y coordinate. C, that is minus 4k minus, this is the minus 4k minus 6 upon k plus 1. Minus 4 into 5 minus 6 upon 5 plus 1, that is minus 4 into 5, that is minus 20. Minus 6 upon 6, that is 20, minus 26 by 6. When we will simplify it, 2 into 13 is 26. 2 into 3 is minus 13 by 3. Okay. 0 minus 13 by 3. This is the ratio in which y-axis divides the line segment. That is okay. One thing we have not written here. See, the y coordinate is minus 13 by 3. And see, we have to find the x coordinate also. Look, the thing is, although the x coordinate will be 0, but let us cross check. The x coordinate is minus k. So minus 5 plus 5, that is 0. The x coordinate comes out. Okay. The ratio will be, see, k is to 1. The value of this is k is 5. So ratio comes out to be 5 is to 1. Okay. The point of intersection is 0 minus 13 by 3 and ratio is 5 is to 1. See, the next question, very good question. If A61, B82, C94 and DP3 are the vertices of a parallelogram taken in order, find the value of P. See, A61, B82, C94, DP3 are the vertices of a parallelogram, they are taken in order, find the value of P. If this type of question comes now, just draw a figure. See, this is a parallelogram, or C is assuming all this AB parallel to CD and BC parallel to AD. So A61, B82, C94, DP. Okay. Now see. First find the midpoint of AC and BD. Now why I am telling to find the midpoint, I will tell you later. The midpoint of AC, suppose it will be M and anything. See, the coordinates of the midpoint of AC is 6 plus 9 by 2 and 1 plus 4 by 2. 15 by 2 and 5 by 2, or just let it be. The midpoint of BD is P plus 8 by 2 and 3 plus 2 by 2. Okay. So what happens, for a parallelogram, the midpoint of two diagonals are same. We keep this thing. The midpoint of two diagonals are same. So midpoint of two diagonals same means what? The coordinate, the x coordinate of midpoint of AC will be equal to the x coordinate of midpoint of BD, and the y coordinate of x point of AC will be equals to y coordinate of x point of BD. Then only it can be same. So P plus 8 by 2 must be equal to 6 plus 9 by 2. Only the x coordinate is required because P is only this. 2 gets cancelled out. 6 plus 9 is 15 and P plus 8 equals to 15. So what we will do, we will take 8 on the next side of the or other side of the equation. P equals to 15 minus that is P equals to 7. Okay. So what you have to do, you have to follow order, that is the midpoint of both diagonals will be same. Keep the coordinates as same and just P plus 8 by 2 equals to 6 plus 9 by 2. That is P equals to 6 plus 9 15. That is P equals to 15. That is 7. Okay. Now see, this is only in the coordinate geometry syllabus in your. This will be very important for board examination. So what we have discussed, the first thing we discussed is the importance of coordinate geometry and why we study the coordinate geometry. Second, the fundamentals we discussed, there's the quadrant concept. Okay. And next thing we discuss the section formula, distance formula, section formula, area of triangle. They will ask any one proof in the examination. This is very important. And see, what you have to do, the first thing you have to draw the figure, and then you have to see, I have explained that P are perpendicular, Q is perpendicular. In the examination, you have to write that P is perpendicular to x-axis and Q is perpendicular to x-axis. Examination you have to write, and in words form, so that the statement could be a little bigger, and then you have to solve this. Similarly, if they ask regarding the section formula, all the statements which I have told or which you have understood, you have to write those in the word format, and then you have to make this, then you have to just solve this. Okay. Similarly, in the case of area triangle, so one thing you should keep in mind, do one thing, only these 3 proofs are there. Revise 2 to 3 times each question by writing your copies. And next thing, the questions which have been discussed in the class, these questions have been taken from the standard books, and only the data will be shown in the examination. Nothing more will be there from this topic. So learn these concepts and solve the questions. Okay. So this is all for today which we have. Bye bye. Have a nice day.